Good morning, students. I am Dr. Noor Tanish, working as Assistant Professor in Department of Physics, Jamshedpur Cooperative College, a constituent unit of Kolhana University. So today I am going to have my lecture on the topic of phase and phase difference, which is from the course of BSc Physics, CC4 Waves and Optics. So phase. What is phase? First you need to understand. If we take any waves carry motion of the particle from one point to another point. Now, the motion of the particle can be carried in the two different ways. One is called transverse wave, another is called longitudinal wave. So let's understand how a phase is this. The phase is the physical quantity. Which what it is? It is the physical quantity which represents the instantaneous displacement and direction of the motion of the vibrating particle. Means it is the instantaneous displacement and direction of the one of the particle. Okay. So there will the another particle will be at the different phase. Means let's see in this figure. Okay, I am taking it as a wave. Then the particle P1 and the particle P2, which are at different instant of time. The total wavelength called 1t. Okay, so this particle direction is this, and this particle direction is this, and it is time t1 and it is time t2. So what we find that the particle p1 and the p2 are at different phase. When a wave propagates in a medium, then all the particles of the medium vibrate in the same manner. They vibrate in the same manner about their equilibrium position. So see, particle here has a tendency to come toward this line, and the particle here has a tendency to come toward this line, and this motion continues. Okay, phase of the different particle at the same instant are different, or phase of the same particle at different instants are different. The difference of the two phases is called phase difference. So if these particles move from here to here, it will take some time. So phase of the same particle at two different instants will be different, or the phase of the two particles P1 and P2 at same instant is also different, and that difference is given in terms of phase difference. Now let's see. The displacement of the particle considering in x direction with respect to the origin will be given by sine wave y is equal to a sine bracket omega t minus kx, where omega t minus kx is equal to phi is called the phase of the particle. So this portion, okay, is defining me the phase, instantaneous phase of that particle. Let phi1 and phi2 be the phase of the two particles at distance x1 and x2 from the origin at the same instant. Okay, then phi1 can be written as phi1 is equal to 2 pi bracket small t upon capital T. Small t is the instantaneous position and capital T is the total duration, total time. Okay, and x1 is the position and lambda is the wavelength. Small t upon capital T, T is the time period. Okay, x1 by lambda, and phi2 will be equal to 2 pi small t upon capital T x2 minus lambda. Now the difference between phi1 and phi2 will be equal to phi1 minus phi2 is equal to 2 pi upon lambda x2 minus x1. Now this difference of phi1 and phi2 is represented by delta phi. Delta phi will be equal to 2 pi upon lambda x2 minus x1, and which will be represented by delta x. Thus what we see, where phi1 delta phi is equal to phi1 minus phi2 is the phase difference between the particle at separation delta x. So this will be, if this is the Consider this is the separation delta x, then the phase difference will be 2 pi upon lambda into delta x. Thus, phase difference is equal to 2 pi upon path difference. Clear? This is from this equation. Okay. Two particles are said to be in same phase. If the phase difference between them is 2 pi, means any particle which is here and which is here, the total difference is 2 pi. They will be considered in the same phase. If you see a particle which is here has the direction there, and similarly here is the direction here, and total path difference from here to here is lambda. So they will be called in the same phase. So if delta x is equal to wavelength equal to lambda, then delta phi will be equal to 2 pi upon lambda into lambda, which will give me 2 pi. Thus, two particles of the medium at delta lambda separation are always in the same phase. So phase is getting continued, means after the completion of the 2 pi, the next particle which will be here at P6 will be having same phase as P1. So it repeats after 2 pi phase completion.